Good afternoon, good evening, and good morning to everyone here. I am Saurabh Sonwani, an early career representative of iLEAPS and convener of this program. With me are co-convener Pallavi Saxena and Stephen Wolf for this event, and both are the scientific study committee member of iLEAPS. We welcome you all to our third episode of Drive with iLEAPS on the Wheel of Science, a global interview series. Today, our guest is Professor Rob MacKenzie from University of Birmingham, UK. However, before introducing him, I would like to say a few words about iLEAPS. iLEAPS stands for Integrated Land Ecosystem Atmosphere Process Study. It is a global research project of Future Earth. It seeks to provide an understanding about how interacting physical, chemical, and biological processes transport and transform energy and matter through the land-atmosphere interface. Like other Future Earth Global Research Project, iLEAPS is a network to link iLEAPS scientists to key societal challenges related to health, biodiversity, climate, food, and fuel security, and ultimately to United Nations Sustainable Development Goals. It promotes scientific excellence through developing international science initiatives that are multidisciplinary through bringing together the modeling community with satellite, experimental, and field observational experts, and through enabling communication and networking across the international science community. It facilitates these initiatives by acting as a communication hub and coordinator of worldwide scientific research in the field of ecosystem, atmosphere exchange, and the impact of those exchange on the key societal issues. Another very important initiative of iLEAPS is promotion of leadership in science through capacity building in developing countries, as well as through their early career scientist network by hosting workshops, ensuring timely and relevant science to be available through their website and training programs. Recently, we conducted an Earth and Environment Day series 2021-22 targeting South Asia. And we have also organized iLEAPS Light Conference 2022, iLEAPS OSFlux Conference 2023. We have successfully conducted Global Interview Series 2022, and recently Global Colloquium Series 2023 is still going on. As we know that there are several challenges faced by researchers in different fields of science and technology. A motivation is always required to drive the enthusiasm to carry forward the research. The key to motivation is to follow the footsteps and journey of renowned and esteemed researchers and academicians that help to set a remarkable goal. So this understanding has been behind the present program to provide researchers, especially early career researchers, an opportunity to imbibe knowledge, inspiration, and zeal to conduct their research in a direction that is fruitful for the welfare of the society. So with this brief introduction of iLEAPS, it's time to start our program with our guest, Professor Rob MacKenzie, who has had a remarkable journey in the field of air quality, climate change, impact, and its mitigation through green infrastructure. So now, here I would like to request Stephen, one of our co-convener of this present program, to introduce Professor Rob. Stephen, now it's over to you.
Yeah, thank you very much for these introduction words, Saurabh. I would like to introduce Professor Rob MacKenzie, and we are really happy to have him here. So Saurabh has explained shortly the idea of iLEAPS, and I think those points following the step of renowned researchers and to have a fruitful welfare of society are really basic columns. And I think there's few people who can explain this better. I think there's no one who can explain this better than Rob MacKenzie. He's actually Professor of Atmospheric Science at the University of Birmingham, and he has a huge experience in computer simulation of air quality on very different scales. He has worked for long years in this area between biosphere and atmosphere, and how plants interact with chemicals emitted, for example, from traffic fumes, and how megacities beside oil plantation can have a kind of difficult living together. And the point of putting the right plants in the right places is something which is a kind of key focus of the current research and of the last years of Rob. Interestingly, he has worked in some different fields of atmospheric science. So he was not only involved in this plant-atmosphere interaction, he has also worked in the stratosphere with the geophysics airplane and with the data there, which is really interesting in a completely different scale. And maybe he will talk a little bit about this point, which is especially for early careers interesting to look that you do not have to stay for decades in the same field what you're doing. Sometimes if you change your area a little bit, that can broaden your understanding, and that does not mean that you close the door in that field which you are actually doing. And maybe this is something which can Rob explain later, which he would like maybe. Yeah, Rob MacKenzie, he's also chair of the Trees and Woodlands Science Advisory Group of the DEFRA Nature for Climate Film. And he's the inaugural director of the Birmingham Institute of Forest Research. And this is an institute which reached the across university to enable science, social science, and cultural science on forest landscapes. And FACE, which is the abbreviation for Free Air Carbon Dioxide Enrichment Facility, is also a keyword where Rob MacKenzie is very professional working in, which means that specific points which are put into research field are getting enriched, CO2 enriched air, and the analysis takes place then how plants are reacting in this ambient which is artificially exchanged with higher CO2 concentrations. Regarding the point social science, cultural science, and natural science and the connection, I think this is really interesting for all iLEAPS related fields nowadays, to see how can natural scientists explain their results to have different approaches in the challenges we have nowadays on our planet. And I think Rob MacKenzie can maybe open the eyes for the audience for this. Thank you very much to have you here, Rob. And I'd like to hand over again to Saurabh.
Great. Thanks, Stephen. So good afternoon, Professor Rob. Now we are formally going to start our interview. So before starting a series of questions, here we are a bit curious about your education, career path, and collaboration you had to help you do the role that you are currently. So please put some light on this aspect.
Well, thank you, Saurabh, and thank you, everyone. Thank you, Stefan, for that lovely introduction. It is a very real pleasure for me to be here and an honor for me to be here. So thank you for the invitation. I guess it is true, as you say, Saurabh, that a lot of my work fits very neatly inside iLEAPS. So I feel very much at home in this community because I have come to consider problems at the interface of the physical environment, particularly the atmosphere, and the biological environment, but always from the side of the physical sciences, because it's always been my worry that biology is too difficult to understand. So I had a very ordinary high school science-dominated education, and then went to do chemistry at the University of Edinburgh. I specifically chose to do chemistry at Edinburgh because I could do an environmental strand that came through in the final year of that degree. So I guess even then I was interested in chemical transformations. They were, I found that very interesting, but I particularly wanted to see how that could play out in the environment, and particularly how I, as a graduate, could make a positive contribution to our environment rather than a negative one. And then I just followed that general thought ever since, doing a an atmospheric chemistry PhD. Well, in the interface between chemistry, ozone chemistry at ground level, and aerosol chemistry and physics. And I guess it was that aerosol connection that then allowed me to step as a young postdoc into the stratospheric area. So I became I guess I got my PhD just in the late 1980s when so a few years after after Joe Farman and colleagues had discovered the ozone hole, and so there was a great flourishing of interest. It was a very exciting time to be part of that stratospheric ozone community where almost everything was up for grabs. There was no fixed understanding. We just had to try and work things through, and that was a very exciting period to be part of. And as I went on through that postdoctoral career there, I got involved in running a large research aircraft called the Geophysica, which was the European Union's research aircraft for high altitude, and was involved in that for the best part of 10 years, which generated lots and lots of very interesting science, but also taught me a lot about running complicated research programs, which I've now come back to with this FACE experiment that Stefan mentioned in his very kind introduction. So then, as I went into my academic career, I continued in the stratosphere, but also picked up again the connection with the tropospheric chemistry, and particularly how vegetation and the atmosphere interact on different scales. And that's really what's taken me through my career. And then just about 12 years ago, another opportunity to make somewhat of a sidestep brought me into this Institute of Forest Research as the founding director. And that allowed me then to set up the FACE experiment, and meant that finally, after all these years, I had to confront the fact that living systems have a biology, and I'm going to have to learn something about it. So that's what I've been doing over the last 12 years.
So hope many of us get inspired with your career journey, a beautiful career journey, right from background of physics, chemistry, along with the biology. And there are lots of things I hope we people learn from your experience. And it will be very much helpful, especially for the ECRs. So as an expert of the field of air quality and the impact of air pollution on vegetation, evidences-based intervention to public and urban practitioner, what are your vision and the most important contribution to the field? That is another question.
Yes, I mean, to start with the end of that question, Saurabh, I suppose it's the numbers speak for themselves, and my most important contribution is some modeling work that we did at urban street canyon scale, so in quite small scales, thinking about whether green walls or green vegetation in street canyons can make a difference to the quality of the air inside that street canyon. And I think we were able to pull out the general factors that are important in that context for either improving or in fact making the air quality worse when you put vegetation into street canyons. And we can maybe talk about that later on in terms of it as a specific topic and how we got there and how we approached it. Thinking about the earlier part of your question, I guess like many academics of my generation, we started off quite a long way from the kind of public and policy interaction that is commonplace and very welcome nowadays. So I think we saw ourselves as producing knowledge, adding our pebble to the great mountain of knowledge, and hopefully other people would read our papers and put them into practice. And so by some kind of magic process, we would actually be contributing to making a difference. But I think now we've learned that knowledge generation and societal change are not, they're not as separate as that very naive idea of mine in my early career. And really now when we set up our research projects, we are already thinking, how can we, are we sure that we're answering a problem that is societally important? And how are we going to take the research and the knowledge that we generate and push it out to into policymakers and the publics in a way that is welcomed by them, so they can pick it up and think about it and come back to us. So again, very much away from a one-directional model of the academics generating the knowledge and pushing it out into the public sphere, to a much more two-way understanding of the interaction between public and policy and science.
Yeah, that's great. I think we must learn, especially early career researchers must learn that whatever the research we are focusing or that we are planning, that must be very much useful, and it should be having some kind of the utility to the public, and it should be very much beneficial for the policymaker especially. So that's great. And our next question that is actually related to one of your statement and the thing that you have just mentioned, that the modeling and related things are very much fascinating for you, and the things that you are working on. And actually, we have gone through some of your publications, and these are very huge scientific impact with a very good citation. So due to the time constraint, we have picked some of them so that we can dig deeper into this context. So these are the publication here I'm just going to mention. One is the effectiveness of green infrastructure for improvement of air quality in urban street canyon, that you have, I think, mentioned in your statement. And another one is model data synthesis for the next generation of forest free air CO2 enrichment experiment. And last one is benchmarking sustainable cities, the role of indicator and future scenario. So can you please put some light on this aspect so that we people can better understand? Yeah.
Right, I'll try my best. So the first one that you mentioned, the effectiveness of green infrastructure, is quite a simple modeling setup. So for those of you who do modeling, it's a box model essentially, but set up so that the dimensionality works well for a street canyon setting. There's a lesson to be learned there. That work came about as a result of very creative conversations with my brilliant researcher co-worker, in fact, Tom Pugh, who's the first author of that paper. So he was my postdoc while we were bringing that together. And it's that creative conversation that I draw out as one of the important lessons to learn from that. But we had been working together on much more complicated large eddy simulations of the urban space because we thought that was the way forward. And subsequently, in the dozen or more years since that paper came out, there have been some very good more complicated models, mostly computational fluid dynamics, so really averaging Navier-Stokes for those of you who care about these things, that have shown some of the complexities of flow around trees and green infrastructure in urban settings. But the strength of the paper that you mentioned, Saurav, was that we were able to conceptualize the problem, or part of the problem, in a way that we could get around it and make a positive contribution that was meaningful and useful, and I think has had some longevity. So the results stand because they more or less come from first principles. So that's one of the beauties of not necessarily trying to make the most complicated model to make the most realistic simulation, because that can be quite a short-lived outcome, because your simulation will be as realistic as that state-of-the-art model until the next time you do a simulation with that better state-of-the-art model. So trying to use the model to build some conceptual pictures, I think, was much more important, much more long-lasting. The other, so I could draw out different stories from the other two. The one that you mentioned last about benchmarking, that comes from the same project as the green infrastructure paper, and is a very different paper. It's a paper that is written with a large, the whole program team, the whole project team, and we were a very broad team from many different disciplines. So sometimes in our setting, when we talk about multidisciplinary, we mean an atmospheric chemist and a physical geographer, which is, okay, a little bit multidisciplinary, but it's really much more interesting when you have engineers, designers, people from the arts, environmental humanities, when you have a really broad team in the project. So broad that actually we spent a lot of time just making sure that we could understand each other. And that is one of the real challenges and difficulties of working in these broad multidisciplinary spaces, that time that you could be writing papers is taken up trying to understand each other. And that's the kind of tax that you have to pay for stretching yourself and giving yourself the challenge of working in that creative environment, hopefully, so that you will be able to say something of value at the end of that hard creative process. And that's what we did with the Boyko et al. Paper, the benchmarking paper. We worked through the basic premise that each of us had and found that commonality, and then we're able to put that forward as a framework. So that's where that paper comes from. And again, I think that's why it has lasting value. But it took a lot of effort. And I think those of you at an early career stage in the audience should recognize that there is a tax, there is a price to be paid for working in those interesting spaces, those multidisciplinary and difficult and complex. Sometimes we talk about wicked problems in those kind of spaces, in just understanding each other and understanding the nature of the problem. And then the third paper that you mentioned is when I made that pivot towards the forest. And that's really a framework paper that makes the argument for why we need to go, in fact, why the facility that I operated and the facility that's just been built, similar facility in the Amazon face, and then there's an Australian facility, eucalyptus face. These facilities, the paper that we were talking about is really the rationale for those facilities to provide the benchmark, the challenge data for the modeling. So two aspects, just to wrap up this answer, sort of two aspects to draw from that. First is, if you write papers that other people can use to say, this is where we need to go to, or this is our next step, you'll find that you're cited a lot. So, you know, those are those are useful papers. They're not not at all the most useful papers, but they can be useful because they do direct the community. And the final thing I wanted to say about that FACE work was to actually connect it back to the first paper we were talking about, to that green infrastructure paper, about the connection between modeling and data. And I think it's really, really important now, much more important than it was at the beginning of my career, to think about how models can inform the next piece of field work, the next experimental work, the next set of measurements, but also how those measurements can challenge and evaluate the modeling that more and more we have to depend on for our policy decisions with respect to climate and clean air.
Thank you so much, Rob, for a very satisfactory answer. I hope there are many more things to work on this aspect, and countries like India is also now focusing on the sustainability related research, green infrastructure, and nature-based solutions. So in such kind of the work environment, your publication and the findings will be very much fruitful for such kind of the study in the future as well. So that's great. And one more thing that you have mentioned that about the projects. So since you have a huge experience of the different kind of the projects, so what is your opinion? What kind of the problems people face when they bring some project, or is it some difference in the case of developed or developing nations or underdeveloped nations? What is your opinion?
Well, there's room for, we need to have every kind of project. So sometimes we can have very well constrained, very tightly defined projects with very small teams and perhaps very small budgets. And sometimes we need big, broad projects that are attacking on a broad front. So they're attacking many different research questions. So we need all of those things. And I think as a researcher, it's good to have a little bit of self-awareness about what you feel most comfortable, in what kind of project you feel most comfortable. There's no point in getting yourself involved in big, broad, rather diffuse projects if your mind is not comfortable with that fuzziness. If you prefer the precision, you prefer to work on your own, that's fine. You play to your strengths. So I think that's the way to try and navigate your way through the possibilities that might open up to you as an early career researcher when you're looking around and seeing what options for a next step are out there. As far as the developing world, as far as the global south is concerned, undoubtedly over the course of my career, there has been, and thank goodness, there has been a massive change away from this unidirectional knowledge transfer from the global north to the global south, and especially this kind of science that is sometimes called helicopter science, where scientists drop themselves into a context in the global south. Scientists from the global north drop themselves into a problem, do their bit of work, write up their papers, and then disappear and never. And the legacy is not really left behind. I think we've gone beyond that. I am so pleased that we have gone beyond that. It's one of the things I'm most pleased to see. Of course, that brings its own complications and difficulties and challenges, and especially with very big projects. For instance, when I was involved in taking a great big Russian ex-spy plane to parts of the global south, we had to think very carefully about how we could bring a local community along with us, because we were looking at air that was 20 kilometers above the head of the local community. It might feel and we were thinking about global scale problems. So we were thinking about the ozone layer in its whole global extent. So sometimes there are difficulties in trying to make that connection back, because we're not talking about something that's relevant to a particular farmer in a particular place, or is to do with a particular river, let's say, something like that. But thankfully, in fact, the global meteorological community, I think, is an incredibly useful global network for that equitable and just science. So if I'm not wrong, iLEAPS, I think, comes down through IGBP and all these various international programs and sits inside that pyramid. And similarly, things like Global Atmospheric Watch and the World Meteorological Organization and so on sit in that pyramid of international collaborations. And that seems to me a very important network to enable just and equitable science to be done.
Yeah, thanks. And you're correct. iLEAPS is lying into that particular domain and lying to that pyramid of with global collaboration. And yes, I'm very much agree that countries, that is from developing, maybe underdeveloped nations and other nations, they might be having a different kind of the issues, problem and constraint, and considering that constraint, people can frame their studies and researcher and development so that they can optimize the result. So related to that, considering your experience, since you are having a very huge experience in the research in this air quality and climate change and related things, so maybe you are having a different kind of the some significant contribution. So here we would like to know that what you consider as your greatest contribution to the science and society.
I think what keeps us all going is the thought that our next big science paper will be our biggest contribution, and especially at this end of a career, when perhaps it might be easier to think about just turning the wheel as I'm going towards retirement. In order to keep that enthusiasm up, I definitely need to be thinking that my next paper will be the biggest contribution. But in fact, that's what I've done in my career. So when you look at those pivots towards from that work on photochemical ozone and aerosol processes in the boundary layer towards the ozone layer, that was, I need to be careful here. I mean, I guess someone's listening to this might justifiably say it's, there's been some jumping on bandwagons, but I guess what I would say is, in my defense, what I would say is that I was always concerned to try and make a significant contribution. So I pivoted towards areas that I thought were open, not areas where I thought there was a lot of work already done and the next significant move was going to be very detailed, very complicated, could be very significant, but it was much more. There are areas where that's that's the way the knowledge is moving. Moving into an area like the ozone layer in the 1990s, so many questions were up for grabs, and that's why I moved in. And similarly, 12 years ago, when I moved into the forest area, it was because it was clear to me that there are big open questions that we can look at. So I'm very proud of many of my papers. You mentioned 3 that are well cited. So of course I'm very proud of those because they have generated some discussion in the scientific literature. But I don't think that's, by any means, I don't think that's the only measure of quality in literature. And in fact, I took part in the UK's research excellence framework, the research assessment that we all have to go through in universities every 5 or 7 years in the UK. I was on the Earth Science and Environmental Sciences and Earth Systems panel for the last one of those, and we very definitely were careful not to consider the citations as the only measure of quality. So I have lots of other papers that I'm keen on and proud of for lots of reasons. Stefan mentioned one, the work that we did looking at how the biogenic volatiles coming from oil palm plantations, when they're next to the urban setting, can set off ozone pollution. I think that was a very neat story and the culmination of some very smart measurements. And there are lots of others, even right down to a closed form approximation of the error function, which myself and a very bright Chinese postdoc put out many years ago, and has just found a very few applications throughout its life. So I'm proud of many of my contributions.
In our opinion, you have already contributed a lot in the field, and there are so much of the very good publication that are actually creating a base of the different researcher to do their research in a very better way. So I think that is still a very good contribution to the science and society. And yes, as you have mentioned already, so we'll be we'll be eagerly waiting for your upcoming publications and research output in near future. So
fingers crossed.
Yeah, finger crossed, yes. So considering your so much of experience in the field of land ecosystem and atmosphere interactions, and you have deal with so much of the international project. So here we would like to know what is your vision? What is your vision and plan to achieve sustainable future by 2030? So, yeah.
Well, there are. Sorry, I'm just interrupting myself because I saw there was someone who had a question, but maybe you can pick that up later on.
So we'll be having a separate question answer session. So whatever the questions will be there from participant, that will pick it out into that session.
Yeah, brilliant. My vision is that we will remember that my vision is that we will remember the second law of thermodynamics and not try and retroactively suck CO2 out of the atmosphere, when by far the easiest thing to do is to prevent the emissions in the first place. And in fact, in the air pollution side of things, we have exactly the same story to tell. So I've lost count of the number of local authorities and local governments and private individuals who want to know, oh, can I plant a tree here to clean up air pollution? Can we do this? Plant some grass over here, put a green roof over there to clean up air pollution. By far, far the best thing we can do to clean up air pollution is to reduce emissions. It's much, much easier to control at source than it is to try and control when everything is diluted away. That's the same for carbon. It's the same for the pollutants that we're concerned with. So that emphasis on sustainable development through clean processes, clean production processes, food production, fiber production, material production, consumer product production, that I think is absolutely the key for us.
That is a great message from this platform, that controlling at source is very much important, and that can be very much can play a very important role in controlling pollution. So trapping pollutants in the atmosphere, it's very tedious task, and if you are controlling it at a source, that will be very much efficient. That's great. So in our other question, since you have very much experience in the field and might be have faced, okay, that is actually related to the question that I have already asked you in case of the project handling, but it is actually based on the some specific domain, the green infrastructure, climate change mitigation through green infrastructure and nature-based solutions. So what is your experience? What kind of the problem issues you have faced when you are dealing with such kind of the project? Is there any specific issues or anything?
Yeah, there's a number of different aspects to that. But I suppose just continuing from where we were at the end of my last answer, I wouldn't want to give anyone the impression that I don't think there's a place for green infrastructure. I think green infrastructure can be very, very much part of our pathway to sustainability. And there are nature-based solutions for air quality and nature-based solutions for climate, which we definitely should employ. The two things maybe I'll draw out. The first one I think I can do quite shortly. With almost everything to do with air quality and green infrastructure, I think we are short of experimental evidence. I think we have quite good modeling around it, and I don't just mean mine by any means. I think there are many people. There are some good. There's a small number of really good measurement studies, but not nearly enough. So I think we're surprisingly, I think we're really short of good field measurements in urban settings, where we've set up the measurements not just to make a sort of estimate of what the air pollution is around the city or around an area of the city, but we're actually looking at the concentration fields in the urban geometry and trying to understand that. So that's my first point. And then the second point is that we should remember that green infrastructure does many things at once. That's good, but we as experts should always be counseling the practitioners who sometimes just say, oh, it will solve air quality, it will solve water, it will solve heat all at once. Well, no, it won't, unless you try and put it in carefully and with some care. So I think we always need to be managing expectations and trying to get people to think carefully about the design of green infrastructure, not just throwing it in. And lastly, I think, or related to that point, I think the behavioral change that green infrastructure makes in urban settings is at least as important as the physical-chemical effect that it has on air quality or water or temperature.
That's great for passing a very significant message that nature-based solution and green infrastructure can provide so much of the benefits, the ecosystem services they can provide. There are lots of benefits. If we are taking care of them, then only they will be providing so much of the benefits. Yes. So here we are fortunate enough to have you as interviewee. being a director, since you are being a director of the Birmingham Institute of Forest Research, so considering your position, so what are the objective and approach or the action plan that you consider to solve the issues related to the science, society, and cultural research related to the forest landscapes? So, yeah.
I think what I might do is, let me see if I can come at that question, maybe from a slightly different angle. But so
Okay.
what you were quoting there sort of was our vision. So we have a vision statement, I suppose, like most organizations, you have to have a vision statement. But we didn't just throw it up there and then forget about it. It does actually mean something. So when we set up the Institute of Forest Research at the University of Birmingham, we went, particularly in the UK in this case, around the stakeholder communities. So we talked to general publics, we talked to policymakers and politicians. Of course, we talked to our academic colleagues and try and understand what they thought the situation was, and professional practitioners, so people who own and manage forests, temperate forests, but forests particularly in the UK. And what became clear is that the problems the practitioners have are not all science problems. A lot of them are cultural problems or social science problems. So it was very clear to me when we were setting up the Institute that if we were going to really honestly face the those owners and managers of forests, whether we were going to honestly try and help them, we needed to have social science and cultural research inside the Institute, as well as some deep natural science, which is mostly focused on the FACE facility, the Free Air Carbon Dioxide Enrichment Facility, which is where we're doing that detailed biology and biogeochemistry, and of course, plant-atmosphere interaction. So again, we're setting ourselves the challenge of being big and baggy enough to accommodate that expertise wherever it exists inside the university, and try and understand what each element is bringing to the table so that we can present a coherent and unified story back to policy, politicians, practitioners, owners and managers, to the professionals. And I think we owe, as academics, I think we owe it to the practitioners to do that work ourselves and not to expect the practitioners to do the work for us.
Great. As you have already mentioned once, that multidisciplinary approach is very much beneficial. So again, you are mentioning the things. So that is a key message. If we are trying to solve any kind of the issues, problem related to the nature, forest, or anything else related to the environment. So this is a very good approach. We must collaborate. We must be having the different expertise in our team if we are really try to going to solve the issues that is existing to that particular area. So
guess what I would say there, Saurabh, sorry to interrupt you, but just
no, it's okay.
That's exactly where I was going. But what I don't want to do is give the impression that, especially to an early careers audience, that you should become very broad very quickly. For some people that's good, and they have that kind of mind that can work that way. But for others, becoming the expert is the right way forward. There's nothing wrong with disciplinary knowledge. There's nothing wrong with that disciplinary depth. But I think the challenge I would give is for you to be able to talk about it to the person from a different faculty that you meet in the canteen or whatever, that kind of general conversation, to be open to what they are telling you and to be able to tell them what you're learning from the depth of your disciplinary knowledge.
Yeah, nothing wrong in that. being in a very specific domain for a research. And yes, after having 20-30 years of research experience that you are having currently, so then after people can plan such kind of the things with so much of experience, so that they can plan better. So coming to our last question, that is my favorite question. So what is your message? What is your message to young scientists working in the field of air quality, climate change, adaptation, and mitigation related research? What do you want to convey them?
Well, of course, it might be a different message tomorrow, but today, I think one of the concepts that I think has come through in the last few years, which I have a strong feeling has some depth to it and some usefulness, is this concept of One Health. The idea that to keep us healthy, we need to keep the planet healthy in a kind of Gaia climate science perspective, but also from an ecological biodiversity perspective as well. So we need to think about animal health, plant health, alongside human health in order for us to have planetary health. And I think that gives us a big overarching paradigm that can guide us forwards and make sure that when we're working in our air pollution areas or in our atmosphere, plant atmosphere interactions area, we are always working inside that bigger paradigm. And I think that it certainly helps me feel that what I'm doing has worth. I might be just adding a tiny, tiny pebble onto the mountain of One Health, but at least I am working inside that, that paradigm, which I think is a paradigm that is for the good of us all.
Thank you for passing a very clear message that if we wish to have a good health in present and future, then we must take care of the planet. We must take care of the all flora and fauna there in the different ecosystem. That's great. So now we end up with this formal interview, and now this platform is open for the attendees. If you are having any kind of the questions, queries from our guests, then you can directly interact. You can first opt for hand raise option, then yes, Shala. Yes, you can speak directly to speaker.
Good evening,
Yes.
sir.
Hi, Shala.
Sir, I have one question. So, by using greater quantities of waste paper stock, but still there is a need for virgin fiber, which is getting reduced, and the problem of solid waste disposal is minimized. We have two distinct types of paper recovery system, like recovery based upon de-inking and intended for printing grade or other white papers, accounting for 5 to 6%, which is very low. And the second thing is recovery without de-inking, intended for box boards and coarse paper. How could you base your fact on the judicious uses and improvement of materials and its process?
Shala, I'm so sorry. I'm not sure I caught the details of your question, but I think it's about waste.
Can you please, Shala, can you please shorten your question? I think this is something related to the solid waste management.
Yeah, I think it's about solid waste.
Yes, sir. Like we talked about the nature-based solutions, so that's why I put up this question.
Yeah. Well,
Yes,
thank you
sir.
for that.
So there are, sir, please go ahead.
I can give you an example
Yes.
of circular economy, because I think the way forward with solid waste, as with every other kind of waste, is to stop thinking about it as waste and to stop thinking about the environment as waste ground, a common waste ground that we can put our waste into, and to start thinking about circular economies. And when nature has a part to play in that circular economy, I think in the European Union at least, this is often called a bioeconomy, where you're seeing that circular generation of value-added products and then waste, which is in fact itself a product that can go forward and regenerate and be regenerative of the original. The example I can give you is from the waste facility. So we add carbon dioxide to the air in these patches of forest. That carbon dioxide comes from anaerobic digestion. So the anaerobic digestion uses food waste. So lorries go out to the supermarkets and collect food waste, which is then taken back to the anaerobic digester. The anaerobic digester turns that food waste into methane gas, CO2, and solid fertilizer. The methane gas is liquefied and used to run the lorries which go and collect the waste. The CO2 is recycled back into the food chain as either there are various uses for food grade CO2 in the food chain, sometimes to do with euthanizing, killing animals like chickens, and there's a whole load of other things like fizzing Coca-Cola and so on. And of course some of it we can use to do our scientific experiment. But ignoring our scientific experiment for a moment, that is a very, very good example, I think, of a circular economy where we're really getting away from the idea of waste or thinking of it as a resource. After all, that's what nature does. The waste that comes out of the back of a mammal is not waste to a dung beetle. It is resource. And that's exactly what we need. That's the mindset that we need. I hope that answered the central part of your question, Shaila, even if it didn't get to some of the specifics.
Yes, sir, you have correctly mentioned about thing, but I guess you have missed out one point. So, we use waste as a productive resources, but sometimes it hampers the environment. Like if we see the case of Bhopal gas treasury, when we manufacture the MIC, it has created havoc in Bhopal, which happened years ago.
Yes, so I guess that's a situation where the circularity is not quite there yet. So it may be a case of
no, that is Shaila. I think that is only associated with the industrial accident. So that was the bit another kind of the case. So
sorry,
industrial accident is a bit different thing, and
okay.
Cyanide was released at that time.
I see. Yeah, of course, industrial accidents have very significant air problems, short-term problems for the atmosphere, but that is a slightly different topic. Yeah, and I don't think we can rely on nature to help us out from that. We should just be better at not having accidents.
Yes, sir. Thank you, sir.
Thank you.
Thank you, Shaila. Yes, Sharfa, you are having some question. Yeah.
Yeah. Hi. Am I audible?
Yes, you are perfectly audible.
Yeah. First of all, thank you, Professor Rob, for your beautiful message. It's about One Health. It's basically about coexistence, and I really like the message. So my question is basically, first of all, so sorry, I would like to give my introduction. I completed my PhD last year. I currently work as a faculty in Department of Environmental Science in a college in Delhi University, in Miranda House College. And so my question is related to, you said that the best thing we can do is control pollution at the source. And I personally think that, there are two ways of controlling pollution. One is you control it at the source itself. Next, when the pollution is already out, you have natural-based solutions or green growth strategies to minimize or mitigate the pollution. So even after having these solutions and so many scientific papers about it, is there a gap in the scientific research? Like my question is basically, what is the gap in the scientific research that exists and that is not yet able to minimize the pollution at the source, even after knowing this, that minimizing at the source will do? So that is my question. I hope I made myself.
That's a good question, Shafra. Thank you very much for that. I think an engineer might say, oh, there's some technology that we're missing, or we have to do better with catalysts, or we have to do better with removing CO2 from the flue gas from the chimneys, from our exhaust. And I suppose a systems scientist or a socio-economic economist would say maybe we need to decarbonize our society. So we take away stop using the fossil fuels, then we have an opportunity to avoid the emission at source, at least of fossil carbon, which is the most important carbon to take away. For classic air pollutants like oxides of nitrogen, I think the catalyst technology is getting there, but of course electrification of the fleet will remove that. The problem remaining then will be particulate matter. And I think for those of us in the air quality, particularly urban air quality arena, the research gap, there's a number of research gaps, but one big research gap is understanding exactly what it is about PM that is causing, it seems there's really good evidence that it's causing deaths to be brought forward. So it is really not good for us. But do we know specifically what sizes? And do we know specifically what chemical composition, or is it a much more broad-based epidemiology? I think we really need to try and get further forward on that point, because the electric cars are not going to stop all the aerosol pollution, but they may change the size spectrum and the chemical spectrum of that particulate pollution.
Okay, thank you so much. Thank you so much, Professor.
Yeah, Pallavi, you are having a question.
Hello, Professor Rob. Thanks for such a fascinating interview, and I personally very much inspired from your work, that is urban green infrastructures. So I have a question. Actually, I am not a modeler. I am done some experiments, the dose response experiments, that is a chamber-based experiments for the plant species. So if we are selecting any plant for air pollution mitigation or for climate change adaptation, then is it necessary to apply the urban green infrastructure model, or only by doing the dose response study we can recommend for the green belt development plan? That is the one question. The second question is, if anybody who is a modeler and is only applying the the model, and on the basis of the model he or she is suggesting that you can use this tree species or use this plant species for air pollution mitigation, so only on the basis of the model he can do that, or is it necessary to do some biochemical or physiological or experimental studies of dose response?
I think you're pointing at a really important area there, Pallavi. Thank you very much for that question. I think I mentioned earlier when I was talking about the papers, the specific papers in Saurav's question, that some of them are useful because they talk about the connection between data and modeling. I think that's really where good things can happen. If you use the model to inform a certain concept of what might work in the environment, but you need the experiments to show that the parameters in the model are sensible. So if the model doesn't take account of physiology that's happening to the plants, it may be getting things very badly wrong. Certainly, the short answer about vegetation and air pollution is that if the vegetation dies, then it's pretty certain that it's not going to do an awful lot of good. I mean, the twigs that remain might do a little bit of good, but really, you need living vegetation. And I think that's the first thing we get wrong when we try and implement these things. And I know you know this, Pallavi, so I'm really just speaking it out on both our behalves. The dose response stuff, I think, is really important and really, needs to be part of that model and data circle. Because do I understand correctly? What you mean is the damage that is being caused to the plant by the dose. Yeah, and again, if your plant is going to be damaged by doing work on our behalf, by this ecosystem service, then we need to think carefully about whether that's okay, or whether we need to put some kind of replacement policy in place or do something else to help the plants, or but at least we need to know about it. So I think you're absolutely right. It's only by marrying the experimental side and the modeling side that we're really going to have a firm understanding of how these nature-based solutions can work.
Thank you so much, Rob, for putting light on this very important issue.
Any more questions from attendees?
I think everybody.
Okay, then I'm having some short questions. If suppose we are going to plan any project or research regarding green infrastructure and nature-based solutions, so as per your opinion, what are the things that we must consider into our study? What are the list of the things that people must consider?
Well, I think you must count. Yeah, I think following on from what I've just been saying with Pallavi, we really must come at this from the atmospheric side and from the plant side, and ask ourselves, can we make relevant measurements on both sides? And we need to be careful about the measurements we make. Because plants in the atmosphere do not just absorb the pollutants, they also displace the air. And so it's very easy to think about measurements in front of and behind a plant and not take into account the fact that the air is being displaced. So you're not necessarily measuring the pollution before and then the pollution that has been filtered after the plant. There are ways you can set these measurements up so that you have a better chance of understanding them correctly. And I think that's what I would plead for. So they don't have to be massive experimental campaigns. They can probably be set up. Some can be quite small, but some of them have to be quite big as well. And especially if we're thinking about particulate matter, because the source of particulate matter is regional scale, at least in the UK and in Europe. There are local sources next to roads of ultrafines and coarse particles from traffic. You could focus on those, but you need to then be careful about the fact that you have this regional scale particulate matter veil. So of course, that might be where vegetation is playing a bigger part on that regional scale. So for that kind of experiment, you need to disperse your measurements and measure for a long enough time to know that you're making measurements that are valid over a whole set of different meteorological conditions. The bigger the scale, the harder it goes to find the vegetation effect as a small effect amongst many other effects which are changing your concentrations all the time. So then you start to get into some quite big science.
Great. Thank you so much for a very classified answer. So, is there any more question from attendees? I think there is no more question now. So thank you so much, Professor Rob, for being with us and sharing your enlightening and motivating experience. Also, thanks for your answers and beautiful explanations of questions raised from all the attendees. So now I would like to call Dr. Pallavi, our co-convener, for her concluding remarks. Pallavi, over to you.
Thank you very much, Saurabh, for giving me the floor. First of all, I would like to pay our sincere thanks to Professor Rob for sharing your very interesting work in the field of land and atmosphere interactions, which is in line with the mandates of iLEAPS. We are very much fascinated with your journey of academic and research, and I really believe that it gives really a strong motivation, particularly to the earlier career researchers, to explore the unexplored areas of research and contribute to the society. Thanks, Professor Rob, for taking your time out from your busy schedule and give us the opportunity to learn about your wonderful work about the in the field of air pollution and climate change mitigation through green urban infrastructure. So I personally very much inspired and looking forward to learn from you about urban greening and nature-based solutions concept, as this is very important point and this is very important area because it established the bridge between science and society. So thank you very much for your outstanding contribution towards cost-effective solutions in air pollution. I also thank the attendees who participated in this event, and last but not the least, the whole iLEAPS team for the smooth streamlining of this program, and Saurabh, our ECR iLEAPS of South Asia and Middle East region, for this great initiative. Thank you so much.
Well, thank you all. And if I said anything of even a little interest, I will consider it time well spent. So thanks everyone.
Definitely.
Thank you.
Thank you very much.
Thanks, Professor.
Thank you very, very much.
Thank you, everyone.
Bye.
Thank you. Bye.
Goodbye.